Hi, I'm Tamar, and I'm going to talk about the time scale of redundancy between prosody and linguistic context. So in natural communication, we transmit information using multiple channels. Of course, a lot of the information is transmitted using verbal content, so the words themselves in language. But a lot of information is also transmitted via other channels, such as gestures and speech prosody. What is speech prosody? Prosody is an umbrella term for the suprasegmental auditory features of the speech signal, such as pitch, loudness, and tempo. And one question we can ask is whether these different channels convey distinct information, or rather are they mostly redundant and all convey the same information in different ways. And in this study, we're going to concentrate on the verbal channel and on prosody and the interaction between them. But importantly, this question and also the methods that we developed can be applied for testing the interaction between any two communication channels in the future. All right, so we want to test the redundancy between two communication channels, and how can we compute that? So here we compute the redundancy between communication channels using mutual information. We follow a previous publication by Wolf et al. That computes this mutual information between the prosody of a given word and the linguistic context or the words surrounding it. So this, under some assumptions, can be decomposed into this subtraction of these two entities. First, the unconditional entropy of just the prosody of the words, which, given a corpus, can be estimated using kernel density estimators. And then we need to subtract this quantity, the conditional entropy of the prosody, given the context. And we estimate that quantity using large language models, which we basically fine-tune to predict the prosody given a representation of the words surrounding it. All right, so we have this method to estimate the mutual information or the redundancy between two channels. And previous publications already showed that there is a significant redundancy between prosody and both past and future linguistic context. So it is possible to reliably predict the prosody of a given word given its past linguistic context, and also given its future linguistic context. Okay? However, this previous study used the entire available context, so the entire past or the entire future, in order to predict prosody. But what will happen if we take only a limited context, so a limited amount of the past or the future, or even just a single word? What happens? Are we able to reliably predict the prosody of a given word given just one word into the past or into the future? In other words, we are here interested in the question of the dynamics of this redundancy. So where in time most of this mutual information is concentrated? Is it in the near past and near future? Or do we really need to take a long scale of the past or of the future in order to reliably predict the prosody? Okay, so this is our main question in this study. In order to address that question, we are manipulating the length of the context that is input into our language models. So in this example, we're trying to predict the prosody of this word hints, given a context of n words in the past and m words in the future. Okay, so let's read that. Can you give me a few hints? Suppose you spoke. So it's pretty evident here from that context that hints is supposed to be a question. So it should sound something like, can you give me a few hints? Suppose you spoke. And so hints would be predicted to have a prosody that is prototypical of a question. So the pitch would go up and the duration would be longer, etc. Okay, so we can compute the conditional entropy of the prosody given a context of n words in the past and m words in the future. And then we systematically vary n and m from 0, which means that only the current word is used for the prediction, to n words in the past and in the future. And we can come up with this heat map representation of the mutual information of this prosody with all of the different combinations of n words in the past and m words in the future. So, for example, this value at 0, 0 represents the ability to predict hints, the prosody of hints given just the word itself, hints, etc. All right, so what should we even expect to be the timescale of prosody and linguistic context? Starting from the timescale of prosody and the past linguistic context that is represented here in this first column of this heat map, we predict it to be a long timescale. For example, in this example that I just presented, looking just at one word in the past, few hints, we don't yet know that this is a question. A few hints, me a few hints, give me a few hints, you give me a few hints, can you give me a few hints? So only when we have that word in the far past, can, we know that hints is probably a question and can predict its prosody. This would be translated into such a trend in the redundancy or the mutual information as a function of words in the past. So it will increase slowly, and at some point it will reach a plateau, and we define the time scale to be that point where the MI reaches the plateau or its maximum. Okay, here around 7 words. Regarding the redundancy with the future, we predict it to be shorter scale. In this example, hints, suppose, you spoke already. The word suppose suggests, I think, that hints is probably the end of a phrase. So even if it's not clear that it's a question, when you look at a word in the future, you can already see that this is a new phrase, and so hints would be predicted to have a prosody prototypical of the end of phrases or of boundaries. So for example, it would probably have a pause afterwards. Okay, this would be translated into this kind of trend with a curve of redundancy as a function of words in the future that would plateau much earlier, around 1 or 2 words. Okay, so what did we find? We computed this heat map, or the redundancy of 6 different prosodic features based on previous literature and features of interest in other studies, but of course other features can also be used in the future. We used the mean pitch of a word, the loudness, the duration, and a pause after a word. We also used prominence, which is a composite feature using pitch, loudness, and duration together to give a representation of prosodic prominence or the stress. We used just the absolute value and also relative to the previous word. And okay, so let's look at each feature a little bit more closely. So you can see here that, for example, for pitch of a word, our hypothesis seemed to be confirmed. So this red line representing the mutual information with past information, you can see that it plateaus around 4 or 5 words, whereas the blue curve representing the mutual information with future context plateaus much earlier, around 1 or 2 words in the future. Same for loudness. For duration, it seems a bit more complex, but still the information with the future plateaus early. With the past, perhaps is lower MI, but it plateaus a bit later. Pause is the feature that showed a clear divergence from our hypothesis. You can see the mutual information with the past plateaued quite quickly, and with the future more slowly, and we discussed that in the paper if you're interested. But for prominence, especially relative prominence, we see a clear trend that confirms our hypothesis. Okay, so to conclude, we show here that prosody is redundant with the past, but with a long-scale past. And we think that this might indicate that although prosody is redundant with a long-scale, long-term past, it is not redundant locally. So it might be unique locally. So it can help us access some information that was available in the far past, but might be a bit hard to access in real-time, real-life communication, in real life, given lossy representations of memory and limited attentional resources. So this might be one function of prosody. The redundancy of prosody with future information is shorter scale, which may be related to limited time processes such as planning or prediction processes that are shorter scale in communication. More broadly, we think that we demonstrate here that examining the timescale of redundancy between communication channels can reveal new insights about their function in natural communication. Thank you.